Welcome students. Welcome again to my another new lecture. I am Muhammad Thanbir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh. In this lecture, we will discuss about the advantages of aggregate in concrete, water property required for good concrete and also seawater influence on it, functions of water in concrete, classification of concrete and also problems associated with concrete. Advantages of aggregate in concrete. Concrete is a mixture of cementitious material, aggregate and water. Aggregate is commonly considered as inert filler, which accounts for 60 to 80% of the volume and 70 to 85% of the weight of the concrete. Although aggregate is considered as inert filler, it is a necessary component that defines the concrete's thermal and elastic properties and dimensional stability. We use aggregate because aggregate are cheaper than cement and it has a high volume stability and better durability than the cement first alone. Water property required in good concrete. Quality of mixing water are mainly considered for performance of concrete in both fresh and hardened state. Impurities in mixing water intervenes the setting time of the past and may produce detrimental effect on setting and durability of concrete. When impurities are chemically active, they may take part in chemical reaction, contributing significant change in setting, hardening, and development of strength of concrete. And to require a good concrete, the water should be drinkable or potable. But some drinkable water may contain a large amount of chloride, sulfate, carbonate, bicarbonate, which may lead to problems in concrete, as they take part in the chemical reaction with cement. Water should be free from suspended solids, and finally water is needed for hydration and workability. So water should be free from all impurities and chemicals that can take part in the chemical reaction with cement and influence the setting time and strength of the concrete. In this regard, past performance of a particular source of water can be used to evaluate suitability of water. If not available, some testing inevitable to evaluate water for setting time, compressive strength and durability. Seawater influence on concrete. Seawater contains a high amount of salt, and that is 3.5%, and a significant amount of sulfate, that is 2000 parts per million. Seawater gives earlier strength to the ordinary Portland cement, and it also decreases the ultimate strength. It accelerates hydration due to the presence of chlorides in seawater, and as a result, sometimes it decreases the ultimate strength of concrete. Seawater is dangerous for steel inside corrosion because it can create corrosion and volume increases up to 6 times of concrete. It also creates dampness, crack, efflorescence. Thus, concrete exposed to seawater should be made with cement of controlled aluminate content and with non-reactive aggregate. Embedded steel should be well covered by concrete of low permeability, and good construction practices should be followed. Functions of water in concrete. Water serves the following purposes in concrete. First, to wet the surface of aggregate to develop adhesion, because the cement first adheres quickly and satisfactorily to the wet surface of the aggregate than to a dry surface. Then, to prepare a plastic mixture of the various ingredients and to impart workability to concrete to facilitate placing in the desired position. And finally, water is also used for hydration of the cementing materials to set and harden during the period of curing, and it is the most important purposes of water in concrete. Classification of concrete. Based on the preparation process, concrete is of several types. First, we will discuss about cement concrete. Cement concrete is widely used in all important engineering construction. It consists of cement, sand and biqua or stones of required size in the proportion of 1:2:4 or 1:3:6 unless otherwise specified. So in short, we can say Cement concrete consists of cement, aggregate and water. The mixed proportion for slab is 1:2:4 and that is for column is 1:1.5:3. Now, advantages of fly ash cement concrete. If we use fly ash, it will reduce cement consumption. It is more durable than ordinary cement. It improves environmental condition and it solves disposal problem related to fly ash slag, as these are used in fly ash concrete. Lime concrete. Lime concrete consists of lime, surki, koa or stones and water in the proportion of 1:2:5 unless otherwise specified. The koa or stones should be soaked thoroughly in the water before mixing. These are mainly used in foundation and terrace roofing. Porous concrete. Porous concrete is a special type of concrete with a high porosity used for concrete flatwork application that allows water from precipitation and other sources to pass directly through, thereby reducing the runoff from a site and allowing groundwater recharge. Porous concrete is a mixture of cement, coarse aggregate, water, and no or less amount of sand. It has a lot of pores or voids in the concrete structure that allows water to pass through its voids. It is not good for structure, but it is used for roof and footpath. High performance concrete. High performance concrete may be defined as concrete with strength and durability significantly beyond those obtained by normal means. It is low permeable concrete or less amount of voids with a high density. It has a rich mixed proportion with a high content of fine aggregate, and the FM of the fine aggregate is 2.8 to 3.2. At the present time, high performance concrete in developed countries usually refers to a concrete with 28-day compressive strength beyond 70 to 80 megapascal. Lightweight concrete. Lightweight aggregate is a relatively new material. For the same crushing strength, the density of concrete made with such an aggregate can be as much as 35% lower than the normal weight concrete. Lightweight concrete made with natural aggregate originating from hard rock has a density with a narrow range. It has a higher cement content than normal weight concrete. It gives better thermal insulation than ordinary concrete. It is used for floating runway or mega float project, etc. It has a narrow range of unit weight and it may vary from 20 to 120 pound per feet cube. Underwater concrete. Underwater concrete is one special type of high performance concrete used in the past, present and in foreseeable future as long as there is need to construct bridges with foundations in soil with high water levels and almost all off and onshore structure. To prepare underwater concrete, it needs admixture. When concrete is at rest, its viscosity is high. It can improve those structures which are near to the seawater. Problems associated with concrete. First one is segregation. It can be defined as the separation of the constituents of a heterogeneous mixture so that their distribution is no longer uniform. It is happened due to the difference in the sizes of particles and in the specific gravity of mixed constituents. Now let's see what are the causes of segregation. Segregation may be caused by over-vibration. It may also caused for over-compaction, a dropping from a considerable height, use of less amount of binding materials, use of gap-graded concrete. Mixed concrete should not more than 5 to 6 minutes. If we mix concrete more than this minute, segregation may cause. Care should be taken when handling transportation and placing of concrete. How can we reduce segregation? In case of concrete, it is the difference in the size of particles and in specific gravity of the mixed constituents that are the primary cause of segregation. But its extent can be controlled by the choice of suitable grading and water-cement ratio, and by care in handling, transporting, and placing of concrete. So in short, air in trained can reduce the danger of segregation. It can be controlled by choice of suitable grading and water-cement ratio. It can be controlled by taking care when handling, transporting, and placing of concrete. Bleeding. Bleeding is one kind of segregation and also known as water gain, in which some of the water in the mix tends to rise to the surface of freshly placed concrete. Water having the lowest specific gravity among constituents of concrete. Therefore, it has a tendency to rise upward. This upward rise of water is known as bleeding or water gain. Bleeding is generally expressed in terms of percentage of mixing water or quantitatively as the total settlement per unit weight of concrete. Percentage of bleeding can be calculated using this equation, which is percentage of bleeding equal to amount of bleed water, that is BW, divided by total amount of mixing water, CW. Causes of bleeding. Bleeding may causes for over vibration, over compaction, use of lots of water, less amount of alkali content, use of blended cement. High temperature within the normal range increases the rate of bleeding, but total bleeding capacity probably unaffected. Bleeding can be controlled by increasing the fineness of cement. High alkali content can control the bleeding. Use of crushed fine aggregate, which contains excess very fine material up to about 15% passing through 100 number sieve, can be effectively reduced the bleeding. How to control bleeding? Bleeding can be controlled by adding of pozzolana or other fine materials or aluminum powder. Air entrainment effectively reduces bleeding. Less amount of water can effectively control bleeding. Proper compaction, control of grading of aggregate, proper bonding in top bar of concrete. Rate of bleeding becomes increasing with the increasing of time, but rate of bleeding becomes decreasing with certain time. That is the end of our today's lecture. Thank you everyone.